Okay, so hey everyone. Yeah, my name's Steven. I'm really excited to present NBSafety today and walk you through how to use it and why we might want it. And yeah, so in the Slack, I posted some instructions for how you might. Sorry about that. Probably should have started this with microphones muted by default. So yeah, in the Slack, I posted a few instructions for how to go about installing. So if you'd like to install and follow along, please feel free to do so, but it is totally optional. And yeah, I'll go ahead and get started then. So what is NBSafety? It is a custom Jupyter kernel to try to make it easier to reason about out of order execution in computational notebooks. So before I get into what it, or like how to use it and what the interface looks like, let me just briefly motivate it a little bit. And during the motivation, I'm going to kind of be harping on computational notebooks a little bit. So I don't want you all to get the wrong idea. I actually think that computational notebooks like Jupyter are really awesome and they have a lot of great things going for them. And just to give a brief overview of three things that I think really set notebooks apart. The first is that it's really, really convenient to kind of incrementally prototype ideas and get immediate feedback. Sorry, what was that? Okay, anyway, it's really easy to prototype ideas immediately compared to with like an IDE, for example, where your code is a little more static. So Jupyter makes it super convenient to try things out. The other thing that I really like about notebooks is that you can intersperse Markdown with code so that it's, for example, very easy to put documentation in line. So that's really cool. And then the other thing I really love about notebooks is the ability to generate plots in line. This kind of goes back to the ability to prototype ideas incrementally. It's oftentimes really difficult to get a plot right the first time. And because all of your intermediate state is in memory, you don't have to like rerun your plot scripts from scratch whenever you want to, for example, change the formatting on an axis or change some coloring around or add a title, for example. So notebooks are great for all of these reasons. But with that being said, notebooks are also really, really hard to use in some ways. Now, let me explain what I mean by that. So the very same thing that makes notebooks great, the fact that all of the state is kept kind of in memory, it also makes it really hard to reason about notebooks because all of this is opaque to the user. So as you're going through and executing things, you're building up all of this cruft in some sense that could affect things in non-trivial ways. So just to give you a quick example of how this might occur in practice, well, not in practice, because this is a very simple example, but let's suppose I have three cells. The first just defines some function, the second just calls the function, and the third prints the result. Now, let's suppose I go backwards to the first cell and I change the function to return something else. Now, what could happen is I could re-execute the third cell without re-executing the second cell in the middle. And oftentimes this constitutes a semantic error because usually in many cases, we want to actually preserve the data flow dependencies when we're working with notebooks. So you might think, well, this is like never going to happen in practice. These three cells are right next to each other. But in reality, oftentimes you'll have a situation where you define some cell, and then, much, much later, we define the cell that depends on it, so we call y equal f of to 140 cells later. And then, maybe at some point we go and change the first cell. And then much, much, much later, we finally use the result of the earlier function call. And you can see that if we look at this, these three cells from top to bottom, the result, the printed result, is not what we would expect if we were to run the notebook from start to finish. So with oftentimes you will have notebooks that grow extremely large, and it's really difficult to manage all of this in your head. It's difficult for users. It's certainly difficult for me, at least. So the other thing is, for some of these issues that can crop up from non-refreshed data flow dependencies, you might not even know about problems until it's too late. So the question is, how do we cope with this? Well, one person on Twitter has in the past said, when dealing with notebooks and the results that you are getting from them, you need to restart and run all, or it didn't happen. Well, okay, you could do that, but then basically we're back to just batch scripts at this point. So it seems like we have this dilemma in some sense. We can either, have safe and reliable notebooks where we trust the results, but we have to run each cell in order exactly once, in which case we kind of lose that really nice interactive aspect and quick feedback. Or we can, on the other hand, use notebooks the way they were intended to be used, but just have to deal with a bunch of really cryptic errors occasionally. Well, this is what NBSafety is trying to address. It's trying to allow you to use notebooks the way you are used to, the way you want to, but while catching these kinds of data flow errors before they occur and suggesting ways to resolve them. So with that said, here are the semantics that NBSafety gives on that previous toy example. So if you recall, we have three cells. We define a function, we call it, and then we print the result. In NBSafety, if we end up redefining the function, so now it returns x plus 3 instead of x plus 2, we get two different kinds of highlights on cells that could be depending on this redefinition. So first of all, cells that reference stale values or values that depend on like a stale version of the thing that we redefined, those are given stale highlights in red here. And similarly, in order to resolve this staleness, cells that help resolve staleness are given these refresher highlights. I'm sorry, is that a question? Okay, maybe not. Anyway, so cells that resolve staleness are given these kind of cyan refresher highlights. So the idea is if we re-execute cell 2, it'll refresh the staleness in cell 3. So when we do so, now the only stale part of cell 3 is its output. And NBSafety suggests that we re-execute cell 3 in order to resolve the staleness in output. And when we do, we get the thing that we would expect to see if we were to run the notebook in succession from top to bottom. Okay, so I'm going to now try and actually show you a little more detail of a little more details of the interface that can't be captured in a static slide. So let me go ahead and try and pull it up, and hopefully, hopefully this live demo doesn't go sideways, although live demos usually do. So the way we, the entry point for NBSafety, it's a custom kernel. So we click on NBSafety here. So let's suppose I have that example that we discussed a moment ago. So I have, let's see, I have a function. It's going to return x plus 2. I'm going to call the function. And just to make things a little more interesting, let's suppose I'm going to, let's suppose I add another test here. Okay. And now I'm going to print the result. Okay, now suppose we want to go back and we want to edit this. So I'm going to return something different from this function now. So now you can see we have our stale and refresher highlights as before. What I want to show you is, let's suppose I don't care about this this cell here. I only want to refresh this cell here and get the expected result for this cell. NBSafety will let me see what I need to do in order to accomplish that by, if I hover over the stale highlight, it'll show me the linked refresher highlight that I need to run in order to resolve the staleness. So both of these in this case say, hey, if you want to get a good value for y, you need to go ahead and rerun cell 2 up above. So we'll go ahead and do that. Okay, now we can see if we want to resolve the staleness in cell 4, in the output that is, we need to just rerun cell 4. So I'll go ahead and do that. Now, what happens, you might ask, if we actually try to run a stale cell? So I'll go ahead and try running this y equals 4 cell. It should be, if we were to refresh y, the semantic result that we would expect is it should be false. Because now we would expect, after refreshing f, y should be equal to 47. Of course, and actually I'm going to, yeah. So, but if we try to rerun it, because it has a potentially stale value, the output says, okay, y, which is defined in cell 6 right here, may depend on an old version of f, latest update in cell 8. Okay, so if we try and run it again, we sometimes, maybe we actually do want to be able to run stale cells. NBSafety will let us do it. So in this case, y was not equal to 4 because I changed it earlier as well. So it actually is false, which is the correct value. But if I wanted to be, maybe it could have been wrong. So if I actually go through the flow of refreshing it, then I can be sure that I have the result that I want. Okay, so let's go ahead and quickly talk about how we actually go about implementing this. So the way this works is NBSafety instruments all of the code in your notebook so that it can automatically build up these dependencies between variables without you having to specify them manually. And then in order to detect potentially stale usages, it uses various static analysis techniques. So here's the end-to-end workflow of what that looks like for every single cell execution. So let's say the first step, user submits a cell for execution. NBSafety will instrument the cell as it executes and compute symbol data flow or lineage. So what does that mean? Well, here's what that looks like if we were to go ahead and run the cell on the right. So first, we define a variable a, and you can see on the right-hand side of a has a constant. So a doesn't depend on anything. Then when we define x here, it is a list containing 2, 3, and a. So this kicks in a lineage rule, and the lineage rule says, okay, make it so that x has a dependency on a. And we define the accumulator variable, and of course, it doesn't have any dependencies. It has a constant on the right-hand side of the equals sign. And then in this for loop here, this also, when we start to execute the for loop, this also causes a lineage rule to kick in, which is that v will depend on variables on the right-hand side of the iteration of the in. So v will have a dependency on x. Now, when we get to inside the loop here, we have an AUGA sign, a plus equals. And so the accumulator variable will depend on whatever it did before, which was nothing, of course, as well as v. So the accumulator will have a dependency on v. Okay, so once we're done running through that for loop, we're going to define this function here. Now, when we define a function, a function is also in some ways a variable. And the lineage rules for a function are any keyword arguments are going to be things that the function depends on. So because foo has a keyword argument z, whose default value is accum, foo will have a dependency on the accumulator variable. And then finally, when we assign t to the call of foo, well, we have two things to keep in mind here. On the right-hand side of the equal sign, we have foo. So t will have a dependency on foo. But then this is also a function call. And inside of a call to foo, there is a reference to a variable in outer scope, which is a. So t will depend on both foo and a. So I can actually show you what this looks like. So let's go back to my notebook here, and let's suppose I have a function. We'll call it foo because I'm not super creative, and then it'll have a keyword argument. Let's actually define one more variable, since I need one more variable for this example. So a equals 7. Okay, so let's define this. So foo returns the sum of x, z, and a, and it has a keyword. It has a keyword dependency on y. So let's go ahead and call foo here. And print the result. Okay, so you might wonder, okay, what happens if I redefine y? Let's make y something else. So I'll go ahead and do so. Okay, now you can see that I need to, actually, let's not redefine y. Let's redefine a. That was what I wanted to show you. So if I redefine a, NBSafety is smart enough to do inter-procedural analysis, and it'll be able to tell us, hey, we actually need to call foo again in order to refresh the value of t. So in order to get a non-stale output for this cell here, I need to go ahead and actually rerun t equals foo of 42, because A changed here. So we'll go ahead and do that. And you can actually see we actually have a different value, and we wouldn't have gotten that if we hadn't refreshed T by calling foo again. Okay, so that is the tracer in a nutshell. Now, the next step is, so that the tracer just computes the symbol lineage. In order to actually compute these highlights, we actually use static analysis to determine whether a cell has a live reference to a stale variable. And similarly, we use another analysis technique called initialized variable analysis in order to determine cells that we can run in order to resolve staleness. And just to give a quick idea of live variable analysis, let's consider the following cell on the left here. It's just an if-else block with 3 branches, if, else, else. And if we compute the control flow graph for this very simple cell or simple program, it has these 3 branches. And if we were to run a liveness checker on this cell, it would determine that the variables num and foobar are live. So why is num live? Because we use it here, okay? And we use it and we haven't defined it above here. So we have a live reference to num. However, foobar, you can see it is defined in this branch here. So why is foobar considered live? Well, it's not defined in every branch. So if there's some branch of a program where a particular variable is not defined and then it's used later, that variable is also considered live. Now, S, on the other hand, would be, I have it listed as dead here, but we can be sure that it's initialized. And the reason for that is in every single branch of this program, of this if statement, it is assigned to. And so these are the sorts of things that we're looking for in order to determine whether a stale variable can be refreshed. Because we want to execute cells that will always assign to a stale variable in order to bring it up to date. Okay, and then once we have this liveness.
Stephen, can I interrupt for a bit, if that's okay?
Yeah, of course, please do.
Sure, sure. So
yeah,
which tools are you using for static analysis of and tracing?
So
tracing, I think you have your own kernel, so that probably makes sense. But for the static analysis, which tools are you using?
Okay, good question. The tracer is using Python's built-in tracing utilities. So the sys module has a set trace method, and it takes a callback, which gets executed for different kinds of events. We actually had to do a little beyond that. So I'll refer you to the technical report for those details. But in a nutshell, we use sys.setTrace in order to do the tracing. For the analysis, we just implemented ourselves. So we're not using any third-party tools or anything like that.
Okay, yeah. Thanks.
Okay.
Yeah.
Sure, no problem. And if you are interested in checking out the technical report, there is a link to it in the slides right here. With all that said, thank you so much for attending this presentation and learning about NBSafety. Before we kick off the self-paced portion of this tutorial, which has those exercises in the Slack link that I sent out a minute ago, I'd be delighted to answer any other questions you might have before we kick that part off.
Hi, Stephen.
Yes, hi.
This is Yixiao from FutureWay, and I'm following your tutorial all the way, and thank you for this wonderful talk. And I followed all the steps provided on the GitHub, but
Okay.
I have run the notebook and also with NBSafety, but it seems like the color bar doesn't show. So is there anything I may miss?
I see. Okay. Did you install are you running Jupyter or Jupyter Lab?
Jupyter Lab.
Okay. Did you install the Jupyter Lab extension?
I believe so.
Okay, I see. In that case, okay, so in that case, I would try again with Jupyter.
Okay.
It should kick in with Jupyter Lab. I would also try refreshing and restarting the kernel and killing the Jupyter Lab instance and restarting it. Sometimes it doesn't kick in right away for some reason. The other thing is I will just make sure that you are running the NBSafety kernel and not just the regular Python 3 kernel.
Okay, sure. So last question is that in the future, if I really want to use this NBSafety in my working environment, so what should I do? I just PIP install it, and that's it.
Yep. You can pip install it, and then for Jupyter Lab, if you do want those highlights, then you do also need to install the Jupyter Lab extension. Unfortunately, we couldn't bundle it directly with pip. For regular Jupyter, all you need to do is pip install NBSafety.
Okay, I got it. Thank you.
No problem.
Hi, Stephen. Thanks a lot for the presentation. It's a very interesting project.
Thank you.
My question was, does this work with NumPy data structures or other things where you can modify one element in an array, for example?
That's a great question. I believe it should. Okay, so if let's say I do x equals np dot zeros 10, and then x sub 1 equals, let's do y equals x sub 1 plus 5, print y. And then if let's say suppose I redefine x sub 0, y should not depend on x sub 0, so this should be okay. Y shouldn't be considered stale after I do this. Okay, so we didn't get any highlights here, so it looks okay. However, if I redefine x sub 1, y should be stale. Now this is actually really hard to get right, so bear with me if this doesn't work. Okay, so it did work. So because y depends on x sub 1, it accurately predicted that we should rerun this cell in order to refresh the stale y. That said, so for simple subscripts like this, it's currently functional. But if I do anything more complicated, like use a slice, for example, this is kind of on the roadmap, but it's not fully precise yet. And so there might be some quirky behaviors for this sort of thing. Great question.
I have one more question.
Go for it.
In a really long notebook, the path that you need to take to refresh everything might get super long. Are there plans to kind of offer maybe like a UI element to help kind of do that in batch so that you don't have to like go back and forth between different cells?
Yeah, so that is also on the roadmap, and the current vision for this is like when I have this stale highlight. Looks like something. Okay, looks like there's nothing I can do to refresh this guy apparently. The idea though is that when I click on this, it will jump to the corresponding refresher cell. Sorry, somebody seems to have the microphone unmuted. But yeah, the idea is I can click on this and it will jump to the refresher cell. But I'm definitely open to suggestions for, better ways to implement this kind of thing. I agree that because we can have these very long range dependencies, it would be better if there's a more automated way to check for what I need to do to refresh.
Stephen, quick question. Why do you
Sure.
have, just out of curiosity, this is a design choice for you. Why did you choose Node as a server for your project? Because there's a dependency on Node on this, it seems.
There is a dependency on, on Node?
Node.js, yeah.
Node.js.
Yeah.
That's interesting. Is this for the lab extension?
Yeah. When I ran it, it says I didn't have it, so I had to get it, and it requires version 10 or higher or whatever. For some reason.
Okay, I see. I believe this is because the Jupyter Lab plugin manager, JLPM, is basically an alias of Yarn, and I believe Yarn depends on
That's
Node.js.
correct. It is Yarn. Yeah, I just checked.
Yeah. And unfortunately for lab extensions, there's not a way to get around that dependency on Node. Yeah, I really would have preferred if it were possible to bundle everything in pip. But for Jupyter Lab, unfortunately, the plugin ecosystem is such that you have to install things through JLPM.
Sure.
And that adds the extra dependency on Yarn.
Yeah, no problem.
Or Node in this case, yeah.
Thanks.
Sure. No problem. All right, well, please feel free to follow up with any other questions that you might have over Slack or over email. I am going to be online on Slack to help with any tutorial steps if anybody gets stuck or anything like that. But otherwise, thank you all so much for your attention and for letting me show this work to you. It's been a long time in the work, and so I'm really excited to get it out there. And I'm going to post a survey in the Slack shortly with solicitation for some feedback. It's totally anonymous, but I would really appreciate it if you could fill out that survey. It'll help me to improve this project and hopefully improve future RiceCamp tutorial presentations as well. So I'm going to post that. And lastly, I will say this is a fairly young project. And if you think it's interesting or want to see improvements, one of the best ways you can do that is to go ahead and give it a star on GitHub. That is a great motivation to continue adding features and fixing issues. If you don't like it, no worries at all. But if you do, definitely go ahead and star it. So I'll go ahead and sign off, and thank you again, everybody.
Thank you, Stephen.
Take care.
Thanks.